Today, we're going to discuss how do you hedge exposures to payables or receivables in foreign currency. This is a part of a transaction exposure management, the risk management in transaction exposure. Now let's look at one example. How do you hedge a accounts payable in euro? It is from the textbook, from page 357. Coleman Company is a US-based multinational firm. They need 100,000 euro in a year time to pay off its accounts payable, to pay to their suppliers in Germany, for example. Here are 4 questions about this management situation. So what if we don't do anything? The manager asks themselves, what is the exposure to this accounts payable? The second one is, if we decide to hedge it, if we use forward contract to hedge it, should we long or short? The third one is, how do you use money market instrument to hedge this position? The last one is about using currency options to hedge it. Should we use using calls, or should we use the puts? Now first let's answer the question about what is the company's exposure a year from now. You can look at the current euro exchange rate to see the trend. Is there any particular trend indication of what a year from now? A year is a long time. Now, for example, if we're looking at the trend, if this is, let me see, this is 5 years, or well, at least for the time being, is the rates coming up, right? In February this year, going down, now it's coming back. So, it's kind of hard to predict. But as far as the risk are facing, is they are worried about the euro dollar. A euro will go, the value will go up. Then you have to pay more US dollar for that euro, for that 100,000 euro. So their risk exposures, they are afraid of the price going up. And sometimes the market will give you some indication as well. Now it seems like a going up, okay, from the recent movement. So here is a summary of the in how do you use forward contracts to hedge yourself. Here we treat forward futures as if they are the same thing, although in real life they are not. Okay, we just treat it for the time being. So a long forward contract is appropriate for hedge when you know you will buy some foreign currencies in the future, and you want to lock in a price. In other words, a long forward position lets you buy something now at a predetermined price. Usually, your risk is the price will go up, so you want to lock in. Now, if you know if nobody really know a year from now, if you have some inkling that the price will go down, in that case, you should not lock yourself. Right? This is using long position. Let me emphasize. You know you will buy the foreign currency. Here the asset is euro. On the other hand, in a accounts receivables, if you know your customer will pay you euros a year from now. Now, as an American firm, you want US dollars, so when you receive the euro, you have to sell it. In other words, a short forward position hedging is appropriate when you know you will sell an asset, here is the euro, in the future and want to lock in the price. That's the second case we're going to study today. Here, I'm just showed you the exchange rate. Every day that you can looking at exchange rate here, overnight, tomorrow rate, spot, next spot rate, 1 week rate, 2 week rate, 1 month rate, 6 months rate, up to like 5 years, 10 years, the longer time years. They give you ask and bid price, but also most commonly people using the middle price. Add ask with the bid price, divide by 2, okay? And you have those rates. It seems the longer you're looking at, usually the rates go up. It's kind of risk a premium built in, right? So if they think the rate might, a year from now, might go up, they decide, oh, let's just lock it in now. Let's go back to our example. So there is a forward rate a year from now. The price is $1.2 per euro. Remember, we're always using direct quote. In euro, we always direct quote, right? So here is the position. Now, this is the chart. Show you at maturity date. Cap T means expiration date, maturity date, a year from now. The spot rate can be anything along that line from 0 up to infinity. That's somewhere around 1.2, 1.3, 1.4, or 1.1, 1, 0.9, those things. You might end it. Now, since you already lock yourself in, you lock yourself in at the price of 1.2. So on that day, if the rate is 1.2, to get 100,000 euro, you pay 100,000 euro times 1.2. You get 120K. You pay 120K US dollar for 1,000 euro, right? This is now why I give you the 45 degrees straight line. This showed you all the possible ST, spot rate on that particular date at the maturity date. Right? So if, for example, on that maturity date, instead of 1.2, it's 1.4. So 1.4 minus 1.2. Wow. For each euro, you save yourself 20. You pay 20 cents less. Right? So here is the 1.2. Here's the profit. On the other hand, if this one, ST equal to 1.0 minus 1 point, you're losing 20 cents. The total. Now, why we say this is losing? Because if you do not have the contract, you don't have the contract at the price fixed at 1.2, you go to market to pay for only $100, $100,000 for a 100,000 euro. But you have a contract. You have ordinary contract. If there is no default, in the case you actually has a loss. A forward contract has the upside risk and downside risk. Right? So you also, if the prediction is wrong, then you might end it with a loss. This is for. So this line is all the possible outcome along the line, right? So here's your gain when the price up, you only pay 1.2. Here's the loss, potential loss. When price down, you still have to pay 1.2, and actually causing certain loss. Now let's look at what the price you pay. What the price you pay is 1.2. In other words, you always pay 120K US dollar for 100K euro, no matter what the rate is. In other words, the possibility on the textbook Exhibit 11.4 showed you the payment with its probability on the vertical line on the probability from 0% up to 100%. Now, in this case, if you long a 1.2 forward contract, there is no uncertainties. You always pay 120K for that 100K euro. Okay? So there's no uncertainties, no risk in the risk. In the sense that no matter what the price is, although the potential loss and the gain is implied by our 45-degree the line. This is the forward contract. Our next slide, that's okay. This is much more clear. Forward hedge. So the first example, we're using a forward hedge. You locked in your price no matter what. So the probability is 100. There is no deviations. All right. That means. And then let's look at second one. Second one is called the money market hedge on payables. Money market hedge involves taking a money market position, borrow from market, local or foreign market, to cover a future payable position. This is very similar to the covered interest rate arbitrage. So that a company can borrow funds in the home currency, US dollar, for example, then invest that, exchange to foreign currency, invest in foreign bank to earn interest rate. So using this technique, you don't have to using forward contract. You're just using bank contract. You sign the contract with local bank and the foreign bank. Let's look at let's using my favorite box approach. We call it roadmap. This is the good method for you to analyze how to using money market to hedge. So here is the box. On the top is domestic market. On the bottom is foreign market. Time 0 means now or day 1. Okay. T1 or T cap T, that means in the future. Now you don't have to have a forward market. You don't have to have a forward market. And sometimes because that is irrelevant in this situation. Here you give me information as for domestic interest rate, foreign interest rate, and the spot rate today, because you have a cross-boarding across over the ocean to put it into foreign bank. So first, draw a box and put the relevant input on it. Okay. Now let's look at our next movement. Excuse me. Now here is my solution. So obviously you need get £100,000 to pay your accounts payable in Germany. This is a year from now. Now, how much that will be in domestic, in foreign market? Its present value of 100,000 pounds. I'm sorry. Here should be using. I'm using pound sign. Actually, it should be euro sign. Okay. Oh, it's a euro sign. For some reason, I put the pound sign there. Okay, it's my mistake. So here should be a euro sign. Okay, how is the euro 100,000 euro present value? You discount it at 5%, equal to 95,238 euro here today. The first step, you go this way, from right to left. Then you know this, that's corner is 95,238 euro. How do I convey to to US dollars. In this case, you times, right? We use the adder bracket. Here is a euro times 1.18. You get dollar sign, US dollars 112381. So you get that number. The second step give you this number. You have like $112,381. If you put in the bank, earn 8% per year interest at the end of the year, a year later, that amount is $121,371 US dollars. Now that is a certainty. There is no risk involved because this is the amount. So in that distribution chart, probability distribution chart, that amount is 100% sure. So you basically create a forward market, a forward price, as a matter of fact. So for that 100,000 euro, you'll lock yourself in with 121,371 US dollars. Now this method is a very good one. The one give you some kind of way to hedge your risk if there's no forward market available. It's through the cross-border lending, borrowing, and using foreign exchange rate to lock yourself in. So this is a good example using money market instrument to hedge. Now remember, you're looking at this way, okay? Looking at present value of that accounts payable in foreign currency, convey to U.S. currency today, and invest in the U.S. Market to get a future value a year from now. Then you have that U.S. dollar versus British pound. Here, as a matter of fact, example is a euro, okay, foreign currency. Now, in addition to the forward market or the money market way to do it, the hedging, the currency call is a little bit more complicated. Let's do some analysis here. A currency call option provides the right to buy a specific amount, specific currency at a specific exercise price within a given period of time. Let me emphasize, give you the right. It implies there is no obligations. Unlike the other two examples using forward of money market, this one is a contingent claim. So the payoff is not strictly telling you what it is. It depends on what the actual at the maturity the spot rate is. A currency option does not obligate you to buy the currency. Multinational firm therefore has the flexibility to let the option expire or walk away. You don't have to do it. All right? They can go to the market to buy it if the price is low enough. You don't using exercise price. All right? So this is a more sophisticated, non-linear payoff. We already did the graphic analysis of options in last week's homework exercise. Here is one example. Along the horizontal line is the future spot price. Here is the X, 1.2. Remember, X is the exercise price. Okay? Now, at the maturity, a long call is maximum ST minus X or 0. So if the price is less than, if the price is less than 1.2, you walk away. For example, 1.16, you walk away. Let the option expire. If, on the other hand, if the spot price is above 1.2, let's say 1.26, you exercise it. You will exercise when it's higher than its exercise price. So here is the X exercise price or strike price. But don't forget, in order to get this right, you have to pay the guy trade against you, provide the liquidity here, 3 cents per contract, each per call. Each contract have 100 calls. Okay, so it's 3 cents. So no matter if you walk away, 3 cents is the cost. So here is the long call position, net position. Usually, when I draw the call, first, this is what I will do. First, I find the exercise price. And going down to the point parallel to the price you pay. The price also called a premium. You draw a horizontal line up to that point. After that, you exercise, you pivot to it. Now, this straight line have a degree of a 45 degree, but how do I know? I need a 2 point, right? 1 point is this here, is the exercise price, and the vertically is the price you pay for that. Here's the other line is the break-even point. Break-even point is the exercise price plus the call premium. Here is 120 plus 3 cents is 1.23, somewhere here. So you have this line, you have this line, you put a ruler there, straight line. You have a straight line along that. Now you will exercise it as long as it's higher than the exercise price. But on the other hand, as a net, it not guarantee you are in the money. Sometimes why? Because you already, for example, it is 1.21. You exercise it. You'll save yourself 1 penny per call, but 1 penny is only 1/3 of 3 cents there. So you're ended somewhere here. But it's better off, right? You still have some part. But if if the point is more than 1.23, then you have pure in the money here, this part. This is how you draw a call. Ideally, you should have those software do this for you. But this is the how do you do that? Okay. Now here they also showed you three. They think that they assuming there are only 3 possibilities. They say that there are 3 scenarios. One is the on that day, the spot rate will going to be 1.16. Second scenario is 1.22. The third scenario is 1.24. Okay. So here, since your payoff for the options somewhere here look like here is the formula, maximum ST minus 1.2. This is the X, right, or 0. So this is the auto money. You don't exercise it, right? How much do you pay? You pay 1.16. You don't pay 1.2, right? But however, you paid 3 cents for this option. So total cost you 1.19. So for 100,000 euro, then you paid $119 for that. Now, case 3. The spot price are all higher than the exercise price. 1.22, 1.24. Then you exercise, you pay 1.2, not 1.22. But Since you already paid 3 cents, so the actual cost, the net cost, is 1, 2, 3, no matter what. Here's your payoff on that. Now this is a good example, show you why this is a contending claim. It depends on what? Depends on the underlying stock price, underlying exercise price. I'm sorry, underlying exchange rate here. Now, here's the difficult part. The author assuming that the scenario happened only 3 states. But in real life, this is very hard to really, those, how do you got? We usually, like a Black-Scholes model, usually assuming a normal distribution table with expected value standard deviation. Now, they did not work on that because it's too difficult for this book. So they showed you a payoff, which sometimes look like this. Using the table, you can look at like this. So here you capped your payment up to 123,000 US dollar for your accounts payable of 100K euro. Anything below, you pay less, right? Below the 120 exercise price, right? Pay less. So here's capped. See the cap? Flat. 1, 2, 3, 1, 2, 3. Right? Then 119. Now this one, they showed you the chart look like this. You capped. If it's above 1.2, you capped pay 1.3K. If below that, you go down that way. This is the result of payment. They pay off of a call option. This is what we call the contingent graph. Depend on the value of spot price a year from now. But you'll find out, wow, this one doesn't look like a call option. No, it is. It isn't. It is quite a complicated calculation. Now, on the vertical line, here is the dollar cash outflow. When you the final result. So anything along that. So let me see this one. Here I give you some illustration how that one be achieved. Here we have a payoff of our call option, long call position, look like this. Earlier I showed you. Now think about the exposure the company are having, accounts payable, compared to the exercise price, 1.2. For example, if on that day the exercise price, the spot price, instead of 1.2, is 1.16, so you walk away from the contract, you pay the 1.16. Here is the benefit. See that? The benefit, you walk away. Here's the plus part. On the other hand, if it is above, if the exercise price, if the spot price is higher than exercise price, you kill the option, you exercise the option, and the break-even point is 1.23. Now here is your gain. Here is the net position. So gain position, if looking at the net, is somewhere gain and the loss cancel each other out. You have flat somewhere here, then going down this way. Let me go to the charts here. Where's the charts? Here they showed you, in the depending on the probability, the currency call option. They have certain, for example, 20% I'll get this one, and 80%. You pay always 1, 2, 3K. 20% get. So what is the payoff? It depends on the outcome. It can be this, can be that. The last one is compare the option with no obligations. Here is no hedging. If these three scenarios occurred, you have payment look like this. So you are calculate its expected value of future payoff. Now this one showed you the uncertainty involved with a future event. Here they assuming a three distinctive state of nature. Okay. So let me move back to the chart. So here is a summary about hedging exposure to payables with currency options. We showed you the contending claim is kind of ice hockey stick, okay? Flat on top, then moving downwards. What the advantage? Now it's pretty effective, and particularly it hedge against for the price move up, but also give you flexibility if price move down. You don't have the honor, you don't have the obligation to exercise it compared to the forward contract, long forward contract. No downside risk. But the disadvantage is you must pay the premium upfront. It's costly. Okay. Now you have to pay the premium. This is why we need to study Black-Scholes model. You need to give a right price for that, depending on future probability. So the cost of a call option usually is more expensive. And also, corporation need to worry about the currency forecast and spend a lot of money on what the currency movement is. Then also have accounting problems on that. Because in hedging, because you're dealing with uncertainty, but the action taking, we're ahead of it. Usually you might causing a loss on one account, a gain on other account. You have to consolidate the net result. That is causing a lot of trouble in accounting system to report what the hedging, the true hedging cost is. Okay. So here the next slide is pretty good. Is a comparison of techniques to hedging so far, Exhibit 11.3. The cost of the forward hedging or money market hedging can be determined with certainty. The currency call option hedging has different outcomes depending on the future spot at the time payable are due. Therefore, we call options contending claims depend on what the spot rate on that day is. Therefore, its value depends upon the underlying asset. Here's a summary. Let's just repeat it again. Forward, straightforward, just using payable in euro times forward rate in euro. 100,000 euro times 1.2 per euro dollar. This is a direct price. So the answer is 120K. Money market, it showed you for 100,000 euro, the price for you is 121,371 using the money market, using interest rate, right? Corresponding interest rate. On the call option, you have to looking at different scenario. Now, this is not very common, to be honest with you. We're using Black-Scholes model, using distribution is much more smooth than only three situation. Okay, commonly use that. But this is when basically to summarize the whole thing you do. And how do you do it? The book the text discussed using based on historic average cost. Let's don't worry about that. Since we are just beginning to learn this technique, so we want to know those basics as we move along. Particularly, you have to study the pricing formula. Otherwise, it's very hard to really appreciate why the option theory is so important. Okay, right? Let's take a break. Or coming back, we will do hedging the accounts receivables.